We're live today at Breakfast Central. Okay, so today we are doing circle geometry, and it's an exciting day. This is our first taped live lesson, and well, hopefully it'll come up nice. It'll be recorded as an MP4 file or MP what file? AVI onto YouTube. So you need to subscribe to the channel. Give us a few likes occasionally. Okay, so again, this is we've trialed it with the year 11s, and this is the first time we've gone live with year 10. Okay, so we're looking at parts of a circle, and this is really baby stuff to start with. So we've got center, okay, center's in the middle, and when you go back to this, you'll see my pen moving in space. It'll be exciting, okay? And the radius is the distance from the center to the circumference. So that's the first part. You need to copy down. I'll give you a pause in a minute. Now, in the second circle, I've left two things blank, and there's a piece of pie which has a mathematical name, and there's a bit on the outside of the circumference which has a special name. Who wants to be first on? Ashley. Which one? Yep. Okay, that's called a sector. Sector, there's no dot above the O. And who else wants to be in part of the first file name? The bit on the circumference is called the arc. And because it's a small one, we call it a minor arc. And I am pausing. Go, copy. And we're back live. Okay, so this time, rather than looking at the circumference, if I draw a line joining the circumference but not going, okay, the center is back here, but if I have a line not drawing, that has a special name. Starts with letter C, has 5 letters, chord is the right answer. Not the musical chord that people are away for musical camp, but it's a chord. And the chord cuts not into pieces of pie like sectors, but it does start with the letter S. Who was that one? Segment? Great, you know your circles. And just to add, there's 2 segments. This is the major segment, and this is the minor. So it's just where halfway is. Okay, so we'll just color our circle again. Close. Okay, so that's the center. Now center is often labeled with an O. Okay, so if I've got 2 radiuses, which is radii, it forms an angle there. And what do you think that angle might be called? It's not hard. It's called the angle at the center. And back on again. Okay, draw another circle. Circles are getting worse, I heard someone say, but we won't name names. Okay, this time I've got an angle, but it's not at the center. What do you think we might call it this time? At the circumference. I heard someone say. Close enough. And we're getting very close now to some actual geometry. So angle at the center, angle at the circumference. Okay, so now let's connect those ideas together, and we'll make it a nice big circle. O's in the middle, and it's a nice big circle, isn't it? So note that this time I've got both angles sitting on the same arc. Okay, so see how I've got 2 angles formed, and just copy that down and we'll pause. Okay, so there's a relationship, and we'll get Monica. Monica, what do you think the relationship might be between the angle at circumference and the angle at the center? So if I call this one X and I call this one Y, Monica, what do you think the relationship is? Yep. X equals half of Y, or Y equals twice X. And copy. And we're live. Okay, here's O, and this time I'm going to put a diameter through, and I'm going to put that there, and I'm just going to clearly mark that so you can see that that's the same arc. Okay, so can you clearly see that I've got an angle at the center and I do have an angle at the circumference. So the question is, what's that angle at the top equal to? Jump in now while we're still live. 90 degrees. And the question is, why? Yeah, because here we've got a circumference which is 180 degrees. So the angle at the center is going to be twice the angle at the circumference. So what you've got, can you picture that? You've got a triangle sitting in a semicircle, and the angle at the top is always 90 degrees. Copy. Okay, so what we've done is we've just added some other triangles. The key is that the base of the triangle, it must always be the diameter. So the base must always be the diameter, and then the angle at the circumference is always 90 degrees. And give you a chance to copy that. And we are live. Okay, draw another circle and don't judge. Okay, so again, I've got an angle at the circumference and I'm going to draw a different color. Now just please note that's the arc. And this time what I'm going to do is I'm going to have, so I've got two different angles, two different circumference positions, but they're sitting on the same arc, and I'll just give you a time to think about it, and we'll put the note in a second. Okay, so we've had some discussion off tape, and same arc, angles at circumference are equal. So if I call this angle X, then that angle will also equal X. And using the same idea, at the top, we have a same arc, which means that the angles down the bottom corners, which I'll call Y, they both are equal to each other as well. And obviously these angles in here, which have got nothing to do with the circumference or the center, these guys must be equal, if I call that Z, because these are vertically opposite. And also you've got angles in a triangle. And